Greetings folks and welcome to My Mind's Madness. In our last video, we talked about IP addresses and how to convert them into binary. In this one, we're going to talk about subnet masks and their relevance, but we're going to have to go over a few of the basics with them first. So what is a subnet mask? Well, similarly to IPv4 addresses, it's written in a format called dotted decimal. Each dotted decimal has what we can know as an octet. And each octet, there are 4 of those in general. Octet consists of 8 bits. However, they're only a subset of values that can be possible in a subnet mask. Unlike IP addressing, where every value between 0 and 255 was possible, in a subnet mask, there's only 9 possible values that it can read. It will either read a value of 0, 128, 192, 224, 240, 248, 252, 254, and 255. These are defined values. A subnet mask will never equal a different value other than these 9 possible outcomes. To understand a subnet mask and why we can only ever have this set of rules is we have to understand how a subnet mask is made. Now, the rule that we need to remember here with subnet masks, and it's pretty ubiquitous, is 1s followed by 0s. And this is a very consistent rule. You will never have a mix match of 1s and 0s. The concept of 1, 0, 1 does not exist in a subnet mask. It just can't happen. We would have to have a series of 1s followed by a series of 0s. That is how subnet masks work. And it works across the full 32 bits. It's not like you'll have 8 bits that look like this, and then the next 8 bits will go 1, 0, 0. That breaks the rule. That creates a combination of 1s and 0s, which were not allowed. The subnet mask will be a string of 1s followed by a string of 0s. The only 2 instances where that rule is broken is if you have only 1s or only 0s. Okay? And even still, the rule kind of holds true because the 1s are, if you had only 1s, then there's just no 0s to be had at the end. And if you had only 0s, there's just no 1s to be had at the beginning. So the rule's still valid, but it's the only 2 exceptions you'll see where we don't have a string of 1s followed by a string of 0s, but that's because we only have the string of the single character itself. So let's look at a subnet mask. Subnet masks are typically written in dotted decimal, like we said. So we can have a subnet mask of 255.255.128.0. That is a valid subnet mask. And what that'll look like in binary is 1, 2, 3, 4, 5, 6, 7, 8, because that is our total of 255. 1, 2, 3, 4, 5, 6, 7, 8, our next total of 255. And then 1, 1, 2, 3, 4, 5, 6, 7, 8. I've done too many. There we are. That's our 128, followed by 0s. 1, 2, 3, 4. Okay. So there we have a valid subnet mask string. But what does this mean? How did we know that? How is this value of 255, 254, 252? Why does that make a difference? Let's go back to our 128 table to find out. Earlier, when we were looking at our 128 table, we made the table of 128, 64, 32, 16, 8, 4, 2, and 1. Now, the rule that got us to this is that every time we did this, we divided by 2 to get the next sum, and we repeated this process. What we're going to do this time is we're going to add a new line underneath this 128 table, and it's also going to start with the number 128. But this time, instead of dividing by 2, what we're actually going to do is we're going to add the value directly across from this number. So 128 plus 64 is 192. 192 plus 32 is 224, We're going to keep that pattern going. 224 plus 16 is 240, 248, 252, 254, 255. And this is where we get those values from, which the subnet mask can only ever be. The first is that if we had the string of 1, 0, 0, 0, 0, 0, 0, 0, that follows that rule. It means that my value would be 128. If we keep going this way, eventually we get to a point where we get all of these values. So here we can see we have this lovely little pattern that's developed where we get all the way up to 255, where we have a string of ones followed by a string of zeros. The only other exception to the rule was where we would have all our zeros put in place, which would give us that 9th value of 0. And that, folks, is a subnet mask. We're now going to go into our next video, which is going to show us how these things work together. How does an IP address and a subnet mask combine to give you something that you can actually work with? But now, hopefully you understand the subnet mask.